Hello everyone, welcome to this episode. I'm making this video after a really long time because I had COVID and I took some time recovering from it. But I am now a little bit fine, so I thought of making this video, and it's a cool question that I wanted to bring to you guys. So this question was asked by Google, and the question states that you are given an array of length n plus 1 whose elements belong to the set 1 2 till n, and it says by pigeonhole principle that there must be a duplicate and you need to solve it in linear time and space. So before jumping on to the solution, let's see what the question actually states. So the first line states that array has n plus 1 elements, and and it should have all the elements in the set 1 2 till n, right? So that means, let's say my array is 1 2 3 2 4. Okay, if this is my given array, you see that there are like 1 2 3 4 5 elements, and all of the elements actually belong to set 1 to 4, right? So here the n is 4. So what it states that no matter what the condition is, we know that there will be a duplicate, because let's say I try to have 1 2 3 3 2. If this is my array, so it has n plus 1 elements, but it doesn't have all the elements between 1 to n, that is 4, which in our case should be 4, right? If the size is 5, that means n plus 1 is 5, and so n plus 1 will be 5. That means n is equal to 4, right? And we don't see 4 here, so this condition can never happen. So we are pretty sure that our array basically has all the elements between 1 to n, and if the size of the array is n plus 1. So that's the question. Now coming to the next part, we need to find everything in linear time and space. So how can we do that? In linear time and space means we are already given n plus 1 array. That means we need to somehow make use of this space only, right? And obviously linear time means we can go over this array once, so we need to do it in O of n. So initially my thought process was that maybe we can make some in place changes, right? So let's say if I come at 1, I basically make this array position as -1. Then I come at 2, I make this -1. Then I come at 3, so for 3 this position becomes -1. Now when I come at 2, I have to make the second position -1, and then I see that there is already one -1. That means I have already come across 2. So then I can find that this is a duplicate element. But it would fail for one of the cases. The cases would be like if I have 4 1 3 2 5 4, right? This is the case. So here the n is 5. That means we have 6 elements, and that we can see. So let's say I am at 4, so obviously by the logic we have to make the fourth position -1, that is this -1. So what we are doing here is we actually lose track of this number element, right? Like this becomes -1. Then what if if instead of 4 here it was 2? Now when I come at, so I make this as -1, then I have, for 1 I make this as -1, for 3 I make this as -1. Now when I come here, I already see -1, and then I've lost track of this number value. And because we cannot use extra space, we cannot make a copy of this array, so this approach won't work. So there is another tricky observation that we need to do, because we are told that the set has to contain all the elements between 1 to n. So that means we are sure that 1 to n elements will be there, right? So what is the sum for 1 to n elements? It's basically 1 2 until n. So the formula is n into n plus 1 by 2, right? This is the sum of first n elements. So we know that n elements are present. Now there is one more duplicate element. Let's say the duplicate element is x. So that x will be present in the array. So if we do one traversal and take sum of all these numbers, it's basically gonna give us sum of n numbers, which is this. So sum of n numbers, let's say, is s. So traversing over the array and adding all the numbers to a variable s is basically going to give us s plus x. So this will be the sum of array, because s here is signifying sum of first n elements and x is the extra duplicate element. So what we can do here is, if we take out the sum of this array, which we can say as s dash, and we know that sum of first n elements is s, so doing s dash minus s will give us x, and that's the answer. Yeah, it was this simple. It took me some time to observe this, but yeah, that's the solution to this problem. Soon, now that I have recovered, soon I'll be making a video on some new cool stuff. It won't be exactly related to interview process, but yeah, stay tuned. Please subscribe to my channel and give me a thumbs up. Thanks everyone.